About a year ago, I purchased an xTool D1 10-watt laser. I ordered it as soon as they announced support for the LightBurn software. I was already using LightBurn for several years with a K40 style CO2 laser. It already had an upgraded control board, but I wanted a laser with a larger bed that was more suitable for some woodworking projects and had room for a rotary tool. I also consider the diode lasers more approachable for people new to lasers, and with some exceptions, rarely recommend CO2 lasers to new users. Almost everything I acquire does most of what I want it to do, and then it's up to me to personalize it or tweak it to do that little bit extra that makes my workflow a little easier or add some functionality. You may have seen the D1 in a previous video showing an enclosure that I built specifically for the D1. I have links in the comments to all the videos mentioned here. I was very happy with the D1 and its 10-watt laser module. Especially for wood, I preferred the cut and engraving quality of the D1 over that of the CO2 machine. But the 10-watt D1 was admittedly pretty slow compared to the 40-watt CO2 machine. When the 20-watt laser module was announced, I purchased it right away and have been using the 20-watt module ever since. A few months later, xTool was nice enough to send me a 20-watt D1 Pro for review, along with their new enclosure. So this video is partially to compare the D1 Pro, which is the red machine, to my original D1, the gray machine. I'll show what's been added or improved. I'll also show you some of the small tweaks I made to the D1 Pro, and also show you some of the modifications I've made to the enclosure, including things like lighting, exhaust, a camera, and an automatic fire extinguisher. For this video, the original D1 is in the custom enclosure I built. I'll show the D1 Pro with the xTool enclosure. I plan to switch the two machines after recording this video, so the D1 Pro will live in the enclosure that I built. Both machines have leg extensions in place, making it easy to use the RA2 rotary attachment. I published a video with tips for using the RA2 Pro, and I'm working on a new one with some interesting and flexible holding procedures that will be published soon. There are many videos that show the unboxing and assembly of the D1 Pro, so I'm not going to go into that. What I will do is mention a few things that are different between the two machines. The first thing to mention is that I've been very impressed with the improved effort that xTool puts into their packaging and into their documentation. The unit comes with goggles, some material samples, and little part storage box. My 20-watt unit also came with a nozzle for the air assist, but it doesn't come with the air compressor. That can be ordered as a separate piece from xTool, or you can get your own little air compressor and connect it to the nozzle fitting. Although the unit comes with a few L-shaped hex wrenches, I suggest getting a set of ball-end hex metric screwdrivers, as they make working with hex socket screws much easier. One of the main upgrades is that the D1 Pro now has limit switches. Limit switches allow you to easily home the machine so that you get a reliable starting point, and this is very useful if you want to use absolute coordinates when you're making your print. I'll go into a little more detail about limit switches in a little while. With the D1, I didn't miss the limit switches too much because I generally like to position the laser exactly where I want it manually, and then use the current position as the starting point for the job. However, many people like using absolute coordinates, especially those who use templates for material positioning. This is also useful when using the camera functions in LightBurn. As mentioned, LightBurn is the program I prefer to use for project design and laser control. I do use xTool software, most notably xTool Creative Space, often referred to as XCS, to do things like configure the laser. For example, I turn off the red crosshairs and use the blue laser spot on low power as a very accurate way of positioning the laser. Also, if you want to upgrade the machine's firmware, or turn on or off the limit switches or the flame sensor or the tilt movement sensor, you do all of that in the xTool software. With limit switches, When you home the laser head moves to the back left corner. That is your repeatable starting point, so you can tell LightBurn that you want to use absolute coordinates for your job. Note that the D1 Pro does not use mechanical contact limit switches. There are sensor circuits on both the X and the Y axis. When the black metal tabs pass into them, the limit is activated and the axis movement stops. It's important that the main cable harness stay clear of the frame so it doesn't block the gantry from reaching the sensors, especially near the rear of the frame. I'm pretty active on the Facebook D1 owner site, often helping people that are new to lasers and new to the D1. It's not uncommon to have people who have just assembled their D1 Pro and wonder why the end stop alarm is being triggered. More often than not, it's because they missed a step or two in assembly and did not connect either one of the two limit switch plugs that are under the X-axis gantry. There's a tiny cable that's very easy to overlook that connects to the limit switch sensor, and the other is a connector that's usually tucked just behind the X-axis stepper motor, and it's very easy to miss these connections. So it's important that both of these connections be in place to avoid the limit switch alarm. For my original D1, I found that the cables were getting in the way of cuts, so I installed a drag chain, and not surprisingly, I've got a video about that too. But I didn't find this necessary on the D1 Pro. However, I did reroute the cables a bit. I found that using the initial installation instructions, the cable harness would sometimes bunch up and keep the X-axis gantry from going all the way back, so the laser would not home properly. So I made a few changes to the way the cables are fastened to the frame. First, I placed adhesive zip tie mounts on the underside of the right side rail and fastened the cable to the mounts. This helps keep the cable from intruding on the project space. Next, I used zip ties placed around the stepper motor to snugly attach the wiring bundle for the first set of plugs. Finally, I added a few mounts to attach and flatten the wiring going to the laser module. I've added a short piece of tubing to keep the wire harness from rubbing against the metal. This approach to fastening the cable makes sure that the harness doesn't contact the rear of the frame. The 20-watt upgrade to the D1 has two sockets at the laser module. One accepts a cable coming from the control board, the same as the 10-watt module, but it adds another socket that accepts a cable from a separate power supply that ships with the 20-watt module. The D1 Pro, on the other hand, has a single upgraded power supply and only one cable that goes from the control board to the module. Another difference between the D1's 20-watt module and the one for the D1 Pro is the orange shield. The Pro is designed for a little better airflow. For each of them, you can remove the air assist nozzle without removing the shield. You can reach the set screw on the nozzle through a hole in each shield. This makes it easier to clean the lens. The D1 Pro has also upgraded the way the shield fastens to the laser module. The D1 uses small hex grub screws that press against the shield to hold it in place. The D1 Pro has two Phillips head screws that go into the shield itself. Also, if you have your laser in an enclosure and that enclosure has an orange light filter, you may want to remove the shield from the module entirely, as it makes it less likely that the shield will bump up against a cut piece that is moved out of place. Or you can avoid cut pieces interfering with the nozzle or the shield in LightBurn because you can add tabs that are tiny gaps in the cut that will keep the cut items in place. When the job is finished, then you would use a hobby knife to remove the tabs to release the cuts from the surrounding material. The D1's focus kickstand is in a fixed position, and when lowered to touch the material's surface, it sets the focus point at the surface. This is ideal for engraving and for cutting thin materials up to about 1/8 of an inch, 3 millimeters, thick. The D1 Pro module has an adjustable kickstand. You can loosen a lever on the right side of the module that allows you to slide the kickstand up a few millimeters. This is useful if you want to set the focus of the laser slightly below the surface. For example, If you want to cut something fairly thick, say 1/4 inch, which is 6 millimeters, you can set the focus slightly below the surface. You do this by loosening the lever, allowing you to move the kickstand in the shield a bit. This means when you lock it and bring the kickstand down to the surface, the focus point is that much below the surface. Note that the lever is a left-hand thread, so it tightens counterclockwise. Another thing that struck me about the D1 Pro is that it's much quieter than the 20-watt D1 because the D1 module fan runs constantly. On the D1 Pro, the laser module's fan doesn't run while the laser is idle. It turns on only when you're running a job. Each of my lasers sit on 1/2 inch boards that are 24.5 inches square. I use spray adhesive to attach two 12 by 18 inch sheets of 26 gauge steel. The steel covers the active laser area and is there for fire safety reasons and is yet another place to affix magnets. Also shown are two 3D printed pieces that the laser's legs fit into. I keep the leg extensions installed, which is useful when using the Rotary tool. When not using the Rotary, I raise the material to a good working height. For example, in my setups, when using the xTool Honeycomb grid, the grid sits on top of a steel mesh basket, which brings the grid to the correct height and also catches any small pieces that fall through the grid. Note that one of the reasons I like the xTool Honeycomb grid is because it's made of steel, and it allows me to use magnets for material positioning and hold downs. I have a video about some magnetic pins that I made and how I use them and magnets with the xTool Honeycomb grid in case you want to make something like that on your own. I personally only run open frame lasers like the D1 or the D1 Pro in an enclosure. There are a couple of reasons for this. One is a safety issue. I don't want a person, or for that matter any creature with eyes, coming into the room while the job is running and inadvertently looking at the laser beam. I want to protect their vision. I also want to protect my lungs, so it's important that I exhaust any smoke or fumes that are created during a laser job. So let's talk about the xTool enclosure. It's very nicely made, relatively inexpensive, and flat packs for easy storage and transport. The pieces go together with hook and loop fasteners, and it's very easy to assemble. You simply place the assembled enclosure over your laser and hook up the exhaust. There's an adjustable panel with a few slots on the right side that allows access to the power switch and USB port, and this accommodates the different levels of leg extension. The enclosure has a transparent filter, so it's safe to view the laser while it's running without necessarily using additional safety glasses. The enclosure has a built-in exhaust fan. This is a 3-inch fan that's surprisingly powerful for its size, and it's likely fine for most people. The enclosure comes with a 6-foot length of 3-inch hose and a couple of hose clamps to attach the hose to the unit. However, because I already have a 4-inch 200 cubic foot per minute exhaust fan mounted for my other enclosure, I've opted to connect the 3-inch port on the xTool enclosure to a 4-inch hose via an adapter. The other end of the hose connects to a 4-inch Y adapter with blast gates that let me open or close either one of the ports, and the fan pulls the air through. The enclosure has a mesh area on the left side for air intake because you need a certain amount of airflow across the workpiece to feed the exhaust fan. Also on the left side is a hook and loop fastener strip that you can arrange to hold some commonly used tools. As I mentioned, I tend to tweak or modify just about everything that I work with. So the first thing I did was try to add some lights to the inside of the xTool enclosure. I found out pretty quickly that the adhesive used on these strips didn't stick particularly well to the coating, which is likely the flame retardant coating on the inside of the enclosure. So I added some 3M Extreme double-sided tape to the back of each of the strips, and this seems to hold it in place pretty well. In the enclosure I built, I added one set of lights to the top of the enclosure, and this works very well because the inside of my enclosure is bright white. However, the interior of the xTool enclosure is black, so I added lights both to the top and to the inside front panel. I have little remote controls to turn the lights on or off. I also wanted a way to mount things to the underside of the lid. For example, a camera for use in LightBurn, and also the automatic fire extinguisher I mentioned. So I cut, drilled, and tapped a piece of aluminum U-channel and mounted it to the underside of the lid by first taping it into place and then securing the channel with some aluminum rivets. This also has the benefit of making the lid more rigid so that it doesn't sag at all in the middle. I also drilled two small holes in the lid. One is for the camera cable, and the other's for the air assist hose. Although the enclosure has a port on the right side where you could bring in the hose for the air assist, I prefer that the air assist come down from the top, so I use 1/4-inch quick connects for the tubing to make it easy to install and remove the tubing. When I want to use the air assist during an engrave as opposed to during a cut, I want to use greatly reduced airflow. So I disconnect the hose and insert a valve with a small length of tubing that I've already set to restrict the airflow. Rather than change the setting on the valve, I just insert or remove the valve as needed, and this works very well. The enclosure I built is taller than the xTool enclosure. I made it taller to be able to use a wide-angle camera with LightBurn. To get the same height with the xTool enclosure, I created a base that's a few inches tall, and the bottom of the enclosure fits into this base. This also lets me add some additional ventilation ports. There are 4 holes drilled in the front piece, and I've added some grills, these aren't fans, that allow for more air to pass over the work. This is especially useful when I have the 200 CFM exhaust fan running. Here's a view of the base, and you can see how the enclosure fits into the aluminum U-channels that are attached to the walls with that same 3M Extreme tape. I'll try to put up some measurements in the comments in case you want to build something like this for yourself. Similar to my original enclosure, I made this out of whiteboard/blackboard that you can get from the big box stores. Another addition that xTool made to the D1 Pro is a flame sensor, and this should detect and shut down the laser when it sees a flame. This is generally a good thing. However, some people have mentioned that in bright sunlight, the flame detector might get fooled and shut down the print inappropriately, so they turn off the feature. As you may have seen in my do-it-yourself enclosure video, I actually added an automatic fire extinguisher that's normally used for car engines. Though I hope it never gets used, this small automatic fire extinguisher gets activated by flame or if the temperature reaches 170 degrees Celsius, and when activated leaves no residue. So it looks to be a very good addition to an enclosure. In any event, I don't run the laser unattended. I'm either in the room with the laser or in the next room watching a laser via a camera mounted in the enclosure. On each of my lasers, I've installed a second camera that gives me a view that I can access on my phone or tablet from anywhere. This is particularly useful if I'm off-site and I want to see the progress of a job that my wife is running. I use the same 3M tape to attach a small steel mending plate to the frame. This makes it easy to mount a Wise version 3 camera that has a magnetic base plate. Here's a typical view from the camera. The wide-angle camera that's mounted to the top of the enclosure lets me use some features in LightBurn. The particular camera I purchased has a 180-degree field of view, and because it has no case, I laser cut a mount from some 3mm plywood, and I fastened the assembly to the aluminum rail I installed. Once calibrated and configured in LightBurn, the background of the workspace can be updated to show the bed and any material placed on it. So one way to use the camera is for material optimization. For example, here I'm moving an object into position on a previously unused area of material. Then when using absolute coordinates, I can confirm the job outline by using the framing buttons. Other uses include capturing images from objects placed on the bed and tracing them into vector shapes. Well, that about wraps it up. It's nice to see that the xTool company is listening to their customers and making improvements. If you decide that an xTool D1 Pro is something that you want to purchase, I always appreciate it if you use my affiliate link listed in the comments. I hope you found some of this information useful and perhaps give you a couple of ideas. Thanks for watching.